Hi, I'm Ariel Ekblaw. I was a student at the MIT Media Lab, and this is my PhD research. The idea is called TESSERAE, stands for Tessellated Electromagnetic Space Structures for the Exploration of Reconfigurable Adaptive Environments. And the idea behind this big structure is that this will be the space habitat infrastructure of the future. So how do we start to build really big structures in space, things that are bigger than our biggest rockets? Well, you can't just fold them or origami these structures up into rockets anymore. You actually need to go modular. You need to think about tiles with magnets on their edges that can dynamically self-assemble. And then once they're out and they're loose, they're able to actually snap together and form a big space habitat. This is an idea that I first had back in 2016 when I was a student at the MIT Media Lab. The first class where I really developed the idea behind what became TESSERAE was Design Across Scales, this incredible architecture and media lab class where they bring in different talks like Skylar Tibbetts, and that was the session that I became really inspired by. I had come to MIT really excited about space, about thinking about zero gravity, how would forces be different, what could we build or design in space that would be profoundly different than life on Earth. And so that class gave me an incredible jumping off point to start thinking about self-assembly in space. The second course that really influenced this idea and became the foundation of the prototype for my entire PhD research was how to make almost anything. This is a famous, much beloved class at MIT that Neil Gershenfeld teaches here at the Media Lab and at CBA. And this class teaches you really from root principles how to do just about everything in engineering that I needed to do to learn to build the prototypes for a space structure. So after those two classes, that's really what began the story of TESSERAE. And then I worked with Joe Paradiso, who was my advisor in responsive environments, incredible advisor. Joe loves science fiction. He really took me under his wing and mentored me through the entire process of getting through an MIT PhD, doing this research, and ultimately we managed to fly a prototype of this concept on the International Space Station. While I was a graduate student here at the lab, I started this group called the MIT Space Exploration Initiative. One of the things that grew out of the MIT Space Exploration Initiative was this Flight Opportunities Program. So I would go out and charter things like a zero-G flight or International Space Station missions, and then eventually even a lunar mission, giving students across MIT, no matter what their background was, an opportunity to be part of human spaceflight, making progress towards human spaceflight, and then even just space research more broadly. And so out of this group, I decided I wanted to spin this out as its own space research nonprofit called Aurelia Institute. And so Aurelia Institute is now the research R&D home that's taking TESSERAE forward to go from a prototype of a space habitat to a real space habitat in orbit. The TESSERAE habitat that you see behind me is representing a near future where we really want to democratize access to space. If you look at the inside of the International Space Station, it looks pretty messy. There's a lot of cables and tubes. It looks like a science lab. So TESSERAE is about the near future where we can really do two things. Build modularly, way bigger than our biggest rockets, really start making science fiction-worthy infrastructure. And then the second piece is to design interiors that are more welcoming, that can be exciting and inclusive for more people to be part of the future of human spaceflight.